Alright, we are on the first lesson of Unit 3. Unit 3 is going to be all about solving quadratic functions. So we're going to leave behind the graphs of quadratic functions, and we're going to be looking at mostly equations. And what we're going to do is we're focusing on the x-intercepts of a quadratic. So I have a graph here still, just so that in our heads we can visualize what we're doing with the math on the graph. When we find the solutions or the zeros or the x-intercepts of a quadratic, what we're looking for, like on the graph, are those 2 points that I just highlighted. That's where the graph crosses the x-axis, and that's what these things mean. Oops. The x-intercepts, solutions, or the zeros are all referring to those points. And remember from our previous lesson, a quadratic can have 0, 1, or 2 different x-intercepts. And so there may be 0, 1, or 2 solutions to a quadratic. And so when we are asked questions that want us to find the zeros, sometimes it will say something like this, like find the zeros of a quadratic like this. Let me highlight it in a different color. Or it will say find the solutions to a quadratic like this. So notice here that on this equation we have y equals, and it's asking for the zeros. On this equation we have 0 equals, and it's asking for the solutions. So essentially those two things are asking the exact same thing. They're just asking, where does the graph cross the x-axis? So there's a lot of different ways we can be asked that question, and most of them mean and require the same amount of math work or the same kind of work. It just looks different because this one has a y and it's asking for the zeros, like where does this graph cross the x-axis, where are the zeros of this graph? And this one says, what are the solutions to this quadratic, because we have replaced the y with 0, and so the solutions to this equation will be the x-intercepts. Anyhow, so this whole unit is going to be about finding the zeros of quadratics, and we're doing that with the equations of the parabolas, not looking at the actual parabola. So there's a bunch of different methods, which is why we're spending an entire unit on this. And we need all of them in our artillery to be able to handle any quadratic that we're given, finding the x-intercepts of any quadratic we're given. So we will just be talking this entire unit about different methods for finding the zeros of a quadratic. This lesson we're talking about 2. The first is taking the square root. So you can use this method whenever there's no middle term in our quadratic, meaning the x term, when there's no x term. So remember our a, b, and c terms from ax squared plus bx squared plus c. In this scenario, we're missing this middle term. When there's no middle term, you can take the square root and get your solutions. And this one is probably the most straightforward and the most probably will feel the most familiar to you because it's solving equations just like we've solved equations for our whole lives. We do have our steps over here. So if you're looking back at this later and you're trying to solve a new equation, try following these steps to get to your answer. On this one, our first step says move everything so that the squared term is isolated. So what we mean by that is, in this equation, I want just this all by itself, which takes a little bit of moving stuff around. First, I'm going to move the 16 by adding 16 on both sides, so that those two things cancel, per se, and we have a positive 16 on the other side and then a 4x squared. I still haven't quite isolated my x squared because it's still multiplied by a 4. So we do the inverse of multiplication by dividing by 4 on both sides so that this goes away, and we're left with 16 divided by 4 is 4. And then we still have this x squared on that side. So I have successfully isolated my x squared because it's all by itself on one side of the equation. So once we've done that, then it says if there's a coefficient on your squared term, divide on both sides. We already did that. That was part of isolating the term. I included it because people often forget that. Next, the steps say square root both sides. Because I have a squared term, or a squared on my x, to undo that we have to do the opposite of squaring something, which means square rooting. So I'm going to square root both sides of my equation so that I have x on one side, because squared and square root undo each other. And then something very important happens on the other side. The square root of 4 is 2. You can check that on a calculator. But in this scenario, both positive and negative 2 work. Because if we're just looking at this equation that we had previously right here, notice that what it's saying is something squared equals 4. So we already know that if we have 2 here, 2 to the power of 2 equals 4. So we're good on that. But what about negative 2? What about this? And the answer is, it's true. That also works. If you multiply negative 2 by itself, negative 2 times negative 2 also makes positive 4. So there are two solutions to this equation, both positive and negative 2, which is why your steps over here have in giant letters. Don't forget your plus or minus, because that's something that people forget. When we square root both sides of an equation, we always have to add a plus or minus, or we're missing an entire solution. I would say it's a red flag if you don't get two answers to these equations here. Because remember, a lot of quadratics cross the x-axis twice. So it's kind of a red flag. It's possible to get one answer or 0 answers, but at this stage, I would be concerned if you don't have 2 answers. So then we have another step, and this often comes into play if you have something in like vertex form or something that you're trying to solve. Anyhow, it just says if the x isn't isolated, add, subtract, divide, or multiply to isolate it. So this is after we've square rooted both sides. On this one, we don't have to do that because the x is already isolated, but in some questions you might. So that's our example problem. Sorry that it's a little bit small. I could fix that. Hang on. There. It's a little bigger now. So we're going to do a couple examples, and I will go through these quickly. Remember that these examples are on the notes below if you need them again after I've finished. So this equation, remember our first step was to isolate the x squared, just like we would isolate the x squared when we're solving anything. This one is already isolated. It's by itself on one side of the equation. So we can move on to, in fact, all the way down to just square rooting both sides. Because this doesn't have a coefficient in front of it, we don't have to add, subtract, or divide to get it by itself. So the only step left to do is to square root both sides, which leaves us x on one side and then positive and negative 4. So we have a positive 4 and a negative 4. You may see this symbol. What that means is positive. You know, mathematicians are just as lazy as all other human beings, and so sometimes we just want to write one number instead of 2. So they use this symbol plus or minus to indicate that there's actually a positive and a negative 4 solution. In math space, it will want you to do this, though, instead. So that's our answer for that one. Number 2, remember, first step, isolate the x. So I'm going to add 9 on both sides so that my x squared is isolated. I have x squared equals positive 9. And now the x squared is isolated, so I can square root both sides. And it will give me x equals positive 3 or negative 3. Remember your plus or minus. It's super important. And that's our answer for that one. One more to try. We're going to have to isolate the x a little bit more here. So I'm going to take the 98 away from both sides so that it moves to my other side here. And then I'm going to be left with negative 2x squared on this side. I'm still trying to isolate the x squared. I'm not quite there yet. I need to divide by negative 2 on both sides because I multiplied, this x squared is multiplied by negative 2. So I'm going to divide by negative 2 to cancel that out. And my x squared is now isolated, and it equals, let's see, what is 98 divided by 2? That's 45 plus 4. So 49, positive 49, you can double check me in the calculator. And now that it's isolated, we can square root both sides, and we will get x equals positive 7 or negative 7. And feel free to use a calculator to square root things if you're not super familiar with all of these square roots. I'm just familiar with them because I do this a lot, so there's no shame in using a calculator. Just keep in mind that the calculator will say positive 7, but negative 7 is also a completely valid answer, so please don't forget that. Okay. Okay, so we already sort of talked about why we need a plus or minus when we take the square root of both sides, why we need both the positive answer and the negative answer. The answer to that is that we're missing a whole solution. Negative 7 times negative 7 also makes positive 49. So you have two answers that both work in this situation, and if you don't list both, then you're missing an entire solution. So we're going to move on to our next method for solving quadratics, and it's called greatest common factor. So this, again, solving by taking the square root should feel very familiar to you. This one is crossing into territory that we haven't super seen before. You can use this method whenever there's no constant term. That's what goes here, constant. So remember our ax squared plus bx plus c. When you are missing this term, the c term, then you are allowed to use greatest common factor. So we're going to pay real close attention to the steps here because they're different than something that we might expect. Like normally we would, okay, so let's think about this. If we were just to not look at those steps and be like, okay, I need to solve this, 3x squared equals 9x, I would want to isolate the x, right? So I immediately run into a problem because what do I have? I have two terms with x's in them, which makes it very hard, in fact impossible, to isolate the x in this whole equation, right? Because you end up with two x's, they're each in separate terms, and you can't combine those terms because they're not like terms. So we immediately run into a problem, which is why we need another method for solving this equation. So looking at the steps, the first one says move everything to one side so that it's equal to 0. So I'm going to, instead of trying to isolate the x, because that doesn't super make sense in this situation, I'm going to instead move everything to one side. So I want to clarify here, when I subtract 9x here, I do cancel this out and that becomes a 0. But on this side, when I have 3x squared minus 9x, I am not saying that I'm taking 9x away from the term 3x squared, because we actually can't combine those two, right? Because x squared and x are two separate terms. So don't think that because I stack them, that's a problem that I find some people have with the way that we write these. Because I'm listing this underneath 3x squared, it doesn't mean that I can combine those terms. Please don't try to do that. It just means that I'm taking 9x away from both sides, and on this side that will look like 3x squared minus 9x because those things don't combine. Hopefully that makes sense. We just have to list them separately because they're not like terms and we can't combine them. And remember, like terms are things with the same variable and the same power, which in this case, it doesn't have the same power, so we can't combine them. So we've successfully completed step 1, right? It says move everything to one side so that it's equal to 0. Done that. Good. Next, it says factor out the greatest common factor. So this is the part where it gets kind of funky. the greatest common factor, what we're talking about is these two terms, 3x squared and 9x. We're trying to figure out what's in common. The reason that we're doing this is because we want to be able to use the zero product property, which we will talk about more in a second, but the zero product property needs there to be a product to work. And we don't have a product here, we have a difference. Reminder that product means multiply, difference means like subtract. So right now we have subtracting two terms. I want there to somehow be multiplication. So we're looking for a greatest common factor. So we're looking for the things that 3x squared and 9x have in common. So I was just helping my ninth graders, working on this greatest common factor idea. And a method that we found was to list the terms like this. I'm going to do this in a different color, so hopefully you know it's not essential, but it's an option if you have a hard time with this concept. So I have my two terms. I have 3x squared and minus 9x. So I asked them, tell me some factors of 3x squared. And so we listed those factors underneath it. So I know 3 goes into 3x squared. I also know x goes into 3x squared. I also know I also know another x goes into 3x squared, right? So that's all of the things that go into 3x squared. And then negative 9x, I know 3 goes into negative 9. I know negative 3 goes into 9. I also know 9 goes into 9. I also know x goes into 9x. And those are all the things that you can divide 9x by to get a nice thing, right? And so then we were looking at our lists for these two separate terms, and we're trying to find things in common. So I know immediately that 3 goes into both of these terms because I have that listed immediately under both of my terms. I also know that an x goes into both of them. I can't take out all of the x's because this one only has one x. This one only has one x. This one has two, so we can only take one x out. But as soon as we've identified all of those things that can come out of both, what we're doing here is we're sort of doing the reverse of distribution. So I'm going to end up with parentheses, and I'm putting all of these factors that I can take out over here out front. So I can take out a 3 and an x out of both of those terms and end up with something that's still nice. And it's still equal to 0, we're going to keep that part. This next bit, we just need to figure out what's left after we take 3x out of both of those terms. So it's nice to look over here, actually, because it might help us a little bit. When we take 3x out of 3x squared, what's left is just an x. And when we take 3x out of negative 9x, what's left is a minus 3. The best way for me to think about this is I double check my answers by making sure that if I multiply these two things, if I redistribute this really carefully, I will get back what I started. So I'm sort of doing, instead of going this direction, I'm going this direction. I'm pulling 3x out. So just double check in your head, what you can ask yourself is what do you have to multiply 3x by to get 3x squared? And what do you have to multiply 3x by to get negative 9x? So we will practice this more, and hopefully it will start making sense. We have successfully done it, though. We've pulled out the greatest common factor out of those two terms, and now we have a product. So even though it's kind of hidden, we have a product, a multiply of 3x times x minus 3, which means that we can use the zero product property. So really quickly, we have sort of a reminder down here of the zero product property. We learned this literally on the first lesson, so it was a while ago. But the zero product property says that if you, actually no, I take that back. I think we learned it when we did real numbers, which is the beginning of last unit. Yeah, or maybe it was unit 1. I'm not sure. Anyhow, the zero product property says that if you have two things multiplied together and they equal 0, those are two qualifiers, right? We have multiply equals 0. Then we know that either one A is 0 or B is 0 makes that thing make sense, right? Because the only way that you can multiply two things together and get 0 is that one of them has to be 0. So we have sort of a built-in two-solution situation here. Either this equals 0, use this, either this equals 0 or this equals 0. And we can use that fact to find two solutions to this quadratic. And what we do is we take them separately. I'm going to take 3x and say, what makes 3x equal, not 8, I don't know why I wrote 8. What makes 3x equal 0? And then you do the same thing for x minus 3. What makes x minus 3 equal 0? And those two things will give you the two options for how to make this product equal 0, right? One of them has to be 0. So what makes 3x 0? And what makes x minus 3 0? And once you have those, it's just isolating the x, just like we're used to. So on this one, we would add 3 on both sides, and we get x equals positive 3. That's one of our solutions. And then we have 3x equals 0. We would normally divide by 3 on both sides and get x equals, but a thought here, 0 divided by anything is just 0. When you use this method, this might be too soon to say, but when you use this method, this greatest common factor method, one of your answers will always be 0. You're doing it wrong if one of your answers is not 0. That's only if you're using this greatest common factor method. That's not for everything, so just to clarify. So for this part of the product, our solution was x equals 0, makes that statement true. For this part of the product, x equals 3 makes that statement true. So we have two solutions, 0 and 3, for this quadratic. Sorry if that was a long-winded explanation. I hope it helps. Also, this sort of method of using the zero product property, we'll all become very familiar with this. We'll use it more and more and more throughout this whole unit, so that hopefully it will become second nature and very natural feeling to you. So again, just a thought about this, that when we have two things multiplied together, if you can make A equal 0, then that's a solution. Or if you can make B equal 0, then that's also a solution. So we can sort of set those two parts of our product equal to 0 and then solve to find what those two possibilities are. So this next part, it says, how can we use the zero product property to decide what values of x make the following statement true? So we have a product here of, of x and x minus 1. So we have two things multiplied together, x and x minus 1 are multiplied, and it equals 0. So either x is 0 or x minus 1 is 0. So to solve this, we would just put this equal to 0, which actually is already solved. We don't have to do anything. Again, like I said, if you don't get an answer that says x equals 0 when you're using greatest common factor, you're doing something wrong. And then we can also set x minus 1 equal to 0. Too zoomed out. Okay, right, there you go. X minus 1 equals 0. And to solve this, we add 1 on both sides, and we get x equals 1. So our two options for how to make this equal to 0 are either x is 0 or x is 1, because both of those make one of those parts of the product equal to 0. Okay, let's try some more examples of these, and then we'll call it quits for today. Yes, okay. And we already sort of talked about this question, why does taking the square root fail in these problems? So we talked about why we can't isolate the x in these problems. And the reason is there's two occurrences of x. We can't isolate when there's two. It makes our isolation step impossible when there's two. So notice again there's no constant term here, and actually they're already all moved over so it equals to 0. That's our first step. So let's move on to our second step of finding what the greatest common factor is between x squared and negative 2x. The only thing that goes into, so the first thing I like to think about is the numbers, and the numbers, or the coefficients in front of the variables, have only one in common, right? This is a coefficient of 1, and this is a coefficient of negative 2. So the only thing that those have in common is 1. They don't have anything else in common. So we can't pull anything out of that, but we can pull something out of, you can always pull out at least one x. Because these definitely have an x in common. And that turns out to be the only thing we can pull out of both of those things. So again, our next job, once we've figured out what the greatest common factor is, we just have to figure out what's left after we take that factor out. So again, what would you need to multiply? What would you need to multiply x by to get x squared? And the answer is x, right? X times x makes x squared. And then the next question you need to ask yourself is, what do you multiply x by to get negative 2x? And the answer is negative 2, right? We have to multiply x times negative 2 to get negative 2x. So we're left with x times x minus 2. So I'm going to just highlight here, we have these two parts of our product, x and x minus 2. So I'm going to solve them separately because of the zero product property. I can make two like mini equations and solve both of those to figure out what are the two possibilities for x for this equation. This is another one where it's like immediately solved once we write it equal to 0. So we have the two options, x equals 2 or x equals 0. You might start noticing patterns and be able to just tell me what the values of x work in this equation before you even write this, but either way it's good. Yeah. Okay. So let's do number 2 here. This one is not equal to 0, so we need to do that first. I'm going to take x away from both sides so that this turns into 0 on that side. And then again, we can't combine those terms. Just because I'm writing it beneath it does not mean I'm combining those terms. The best way we can write that is x squared minus x. Now that they're both on one side and equal to 0, we can look for greatest common factor. The two factors are x squared and x, which hopefully you can tell that the only thing that they have in common is an x, and technically a 1, but that doesn't do anything for us. So we can take out an x, and again, the question should be, what do you have to multiply x by to get x squared? And the answer is x, right? We multiply by x. X times x makes x squared. And then what do you need to multiply? So this is where it gets kind of weird. What do you need to multiply x by to get negative x? And I want to remind you that this is like, there's like an invisible 1 in front of that x, negative 1 in particular, that we don't need to write because when there's just an x written there, we assume that there's just one of them. But when there's not an x to write, we do have to write that negative 1 because otherwise it doesn't make sense. So the answer to our question is x times negative 1 makes negative x. So now we have the two parts of our product that we can set both equal to 0. X minus 1 equals 0. We add 1 on both sides, and x equals positive 1. And on this part, it's another one that's like immediately solved because there's nothing to divide. Yeah, so we have an x equals 0 and an x equals 1. Both of those answers, if you were to plug in x equals 1 into this function right here, you would get 0 as the result. So, and you would also get it if you plugged in 0 here. That's what our goal is. We're trying to find values of x that make that true. Okay, one last one here with some bigger numbers for us. Again, the first step is to make it equal to 0, so move everything to one side so that it's equal to 0. So we're going to take away 28x on both sides. This makes 0 on that side. Again, I'm not combining like terms. I'm not combining those two terms just because they're beneath each other. I'm just writing that so that I know it's on that side of the equation. Can't combine them because they're not like terms. There we go. Okay, so our next step is, now that we have those all moved over and it's equal to 0, we can try to use the zero product property, except for that we don't have its product, so we need to find something that goes into both of those terms, the greatest common factor here. So hopefully you can tell that there's something in common with those numbers, right? 14 and 28. 14 goes into both 14 and 28, particularly negative 14 goes into both. So I'm going to say that negative 14 is what's the greatest common factor between the coefficients. And then with the x's, of course, one of them has an x squared, the other one has an x, so the greatest common factor is x between those. The biggest thing we could pull out of both is an x. So now that we have our greatest common factor, I can write that out front, leave myself some parentheses, and now we need to ask ourselves, what do you multiply by negative 14x to get negative 14x squared? And the answer is x. Next we have to ask ourselves, what do you multiply negative 14x by to get negative 28x? 14 goes into 28 twice, so the answer will be a positive 2, because positive 2 times negative 14 will make negative 28. And then the x from the negative 14x will be there as well. So now we can really use our zero product property because we have this part of the product and this part of the product, because there is a multiplication in between that. And we can solve both mini equations to get our answer. And take away 2 on both sides, and it'll give me x equals negative 2. That one says negative 14x equals 0. We would need to divide by 14. You might already be able to see that that's got to be 0 because they're multiplied together, so in order to make that 0, it would have to be 0. So, those are our two answers, 0 and negative 2. So hopefully this lesson made sense. Please remember that I do have Zoom meetings every Friday if you have questions. So please let me know or shoot me an email so